Hey everybody, this is video number 46 and we're going to talk about balancing equations today. So this is the summary at the beginning. How do you determine if a chemical equation is balanced, and how does the law of conservation of matter relate to chemical equations? Okay, here we go. So consider this chemical reaction. So we have hydrogen gas plus oxygen gas is yielding some water. Does this follow the law of conservation of mass? Well, put me on pause, and what I'd like you to do is give me how many atoms of hydrogen and oxygen are on the left, and then how many are in our product. So H's and O's on the left and H's and O's on the right. Go ahead and put me on pause. So conservation of matter says that in nature all reactions happen at equilibrium. Both the matter and the mass have to be equal for the reactants and the products. This equals balanced chemical equations. So what are we going to be doing? Well, we're going to be determining that the amount of elements are equal on both sides. Why are we doing this? Well, because it occurs in nature. And how are we going to do this? Well, that'll be in the next video, but I'll just give you a quick coming attraction. It's going to involve discovering those coefficients that go in front of it. So first step, count the atoms. So that's what I was having you do with that first reaction we were looking at, and then you write them down on each side. The second thing you need to do is you need to determine if they are equal. So all that is you look at the amount of hydrogen on the left and the amount of hydrogen on the right, and if they're the same, then they're equal and then they're balanced. Now the deal is you have to have all of the elements balanced. You can't have just one. So in our equation from before, you have to have both hydrogen and oxygen. Okay, so we're going to look at two different examples here, and we're going to discover if they are balanced. So remember, there's two steps that we are going to go through. So the first step, of course, is always just writing down your equation. So do you remember what Hg is? Hg is mercury. And remember, we are going to decide how many of each element on each side. So like my friend, the count there, we need to do the same thing. So over here, we have Hg and O. So we're going to set ourselves up here. So how many Hg do I have? Well, is there a subscript written here? No. If there's no subscript written, we know that this is going to be a 1. How about here for oxygen? Same thing. There's only a 1 here as well. So let's go look on this side. So I should have the same elements. Remember, conservation of matter tells me I should have the same elements on both sides. How many mercuries here? Well, I have 1 here. But look at here. How many oxygen do I have here? Well, I have 2. So our issue is oxygen on both sides. We need to make those equal because we know that's what happens in nature. So is this balanced? No. So the answer is not balanced. In the next video, I'm going to show you how to actually go ahead and balance these. So just to illustrate the point here, what's not balanced is our oxygen. So again, I always like to make a T-chart. I think it's easier to keep things separated. And then I always like to start with a list of elements that I need to deal with. So I know I have to deal with zinc, right? Because it's right here. What's next? Well, hydrogen's also here. And who else? Chlorine is also here at the party. Okay, so we should, by conservation of matter, have the same thing on the other side. So I have zinc, I have chlorine, and I have hydrogen. So now our only job is to go back through and count. So how many zinc do I have here? Well, I have 1. How many hydrogen do I have here? Well, remember, I have a 2 for coefficient in front, so that means 2 times 1 is 2. And then I also have 2 times 1 for chlorine is also 2. So let's go look on the other side over here. So look at no coefficient in front, no subscript, so that means I have 1. Look at chlorine here. Chlorine's got a subscript of 2, so I know I have 2. And the same thing with hydrogen. I've got a subscript of 2, no coefficient, so we know this is going to be 2. So let's take a look. 1, 1, good. 2, 2, perfect. 2, 2, perfect. So you would come back through and say, this is balanced, just the way it is. Balanced. Yay! Smiley face. Okay, so I hope that went well for you. Okay, so we're back at summary time. Again, how do you determine if a chemical equation is balanced? How does the law of conservation of matter apply? Thanks!